Hello. I guess I have one concurrent viewer right now. Just give me a sec. I have to post about this on my story. Oh. Gotta get some people in. What's going on, people? I gotta grab a phone charger really quick. I'll be right back. Phone charger acquired. Oh. Nice. All right, let's let some people join in. I don't know how busy it's going to be right now. I am a bit new to streaming. This is only the third time I've done this, so throw on the lo-fi stream as usual. Weird, is it showing? Oh shit. Okay, the stream's still going, okay. 4 concurrent viewers. Alright, so it is working. Anyways, what's going on, guys? I am currently doing a little PixInsight updating as we wait for some people to get in here to start editing this image. This is M106 data, which is pretty good, and I'm just trying to get Star Exterminator installed here. But while we're waiting, let's do a little gradient removal. So I'll show you the RGB data. For some reason, the RGB data is way sharper than the Loom data. Not too sure why, but anyways, here's the RGB. Pretty freaking crispy. See little faint galaxies everywhere in the image. But we got to gradient correct this image here. And I use a Astropixel processor to do pretty much all my gradient removal just because it's way better than DVE. Also, check this out. It's like a galaxy cluster thing going on down here. That's pretty cool. But yeah, there's some gradienting going on because I did shoot some of this last night with the moon. It won't be a big factor, but there's still some stuff to get rid of. Looks like PixInsight's done with its stuff too, so we're just gonna restart PI real quick. and then we'll have Star Exterminator in PixInsight, which should be a bit nicer than running it in Photoshop. And I mean, even look at this companion galaxy here. Pretty cool. Anyways, oh, there's PixInsight. Thank you. What I wanted to do is input my license for this. Oh no, I showed my license key on stream. Oops. Hopefully that won't come back to bite me in the butt. I doubt it would. I used a 16-inch Arcos telescope at Sierra Remote Observatory. So seeing is between 1 and 1.5 arc seconds throughout capture. So very good seeing. And it's also got a ZWO 6200 on the back, so I'm sampling at like 0.2 arc seconds per pixel, which is a ton, but we're also using an AO unit. Who knows how much the AO helps? I don't. And we're just gonna try and clean up this background here. This galaxy, I'm pretty sure, is one of the Apple backgrounds. At least an up-close Hubble image of it was. But this does have quite a bit of data. I think it's like 200 10-minute exposures or something crazy. So a fair amount of hours, probably 30 something. All right, well, let's get into it. These were 10-minute subs, and there's a lot of them. But let me load up the Loom and the RGB. We can get a good look at these. So there is the background removed Loom, which probably needs more treatment, and here is the, oh sorry, that's RGB. This is the Loom. And I'm pretty sure this, no, this doesn't have a run of deconvolution on it. You have wife? Lanchin, is that you? Is that Lanchin? Yeah. I'm pretty sure that's my girlfriend. It has to be. Anyways, we didn't do deconvolution on this, so let's do deconvolution on it. My framing was messed up for part of the capture, so there's like this banding artifact in 2 places. I think I'm just gonna stretch it, like not super hard, and then we won't have to worry about that. But we'll see if it becomes a problem or not, in which case maybe we'll reintegrate. Let me look at an older iteration of the Loom. See if the stars look different. The stars look the same, so I don't think I saved the deconvoluted image. But I also think I stretched the Loom earlier. Yeah, okay. Actually, I did save my deconvolved image. This one, of course, is pretty bright. I did not run HDMRT on it yet, which we're going to have to. But I don't see the artifact super bad in this, so we're going to proceed forward. Of course, we're going to have to give everything a 180-degree flip, and that's a good opportunity for a new process icon. Flip 180. Have to remember to save these. I always forget. Save process icons. There we go. Overwrite. Yes, yes. All right, so the first step is, I think we're gonna color correct this. We might even crop it. I'm not sure. I think I'll postpone cropping in case. Oh no, we can do a little cropping. Yeah, this top corner is all, top edge is messed up. So we're just gonna crop to get that whole stacking mess out of the way, and I'm gonna do it to both images. All right, statistics should be a bit more realistic now. And then I'm gonna hit it with the autocolor script. It's not Lanchin. That's a shame. My girlfriend has this joke where she has like a TikTok account where she offers to be a wife. It's pretty funny. She plays a character on TikTok. Anyways, it's a common question, so I thought it might have been my girlfriend, but it's not. No, I'm not a scientist. I just take pictures. I take pictures and I write a little bit of code. So I'm slightly into the science bit, but not very much at all. How much does it cost to rent time on a telescope like that? So the data from this is actually available for like $250 a month. So it's probably not that bad time-wise because this is imaging pretty consistently. But if you were to pay for time on a different telescope, it might be quite a bit. So hard to say, but you can check on like Chiliscope or iTelescope. There's a bunch of similar scopes out there that people are running. What's up? We're just editing some M106 data here. Pretty cool. Grand Design Spiral Galaxy, I'm pretty sure. Oh, I want to look up M106 Galaxy. I just want to look at some other pictures here for inspiration before I get into it. That's the Hubble image. That's pretty cool. That one's pretty good. I might be getting pretty colorful on this one, not gonna lie. But I have a really insane amount of detail. Like, this is more detailed than any others I've seen so far. I did shoot HA to try to get these wings. So we're gonna be trying to blend in HA to pull those out too, so that'll be interesting. Yeah, I have thought about doing microscopy before. It looks very fun. I don't know how expensive it is though, and I don't know anything about it. If I could just have someone like get me a microscope setup so I don't have to worry about gear selection, then that would make life a lot easier. But I really like Levon Bis microsculpture. That microscopy series is really cool. Find it very inspiring. Man, there is so much detail. This is messed up. It's ridiculous. This galaxy was super high up in the sky. You're gonna get the night vision if you do binos or binoculars. Oh, hey Ramsey. Yeah, I've been seeing your night vision stuff, and it's like been inspiring me to maybe get night vision some more. Right now, I'm not gonna buy anything right away, but there's this company, Nocturnality, that I asked if they would send me some just to shoot content with, and they said sure. So I'm gonna wait for Nocturnality to get back to me. They have some paperwork to send me, and then I'm gonna try out a PVS 14. But I kind of want I want a PVS 14, the L3 unfilmed, ideally. You can email. I think my email is linked in my bio, or yeah, I think that might be easiest. Anyways, there's the RGB. You can see a little bit of that HA wing still made it in there. Oh, the Milky Way is so cool. It's unbeatable. I've ran into a couple people at star parties that use NVGs, and I've gotten to take a look through a bunch. That's where I got my footage from, and it's really cool. Yeah, L3 unfilmed is the best. What I would like to do is get that Teleview adapter and then put it on a big Dob or something. Question: when shooting galaxies, should I get a Rasa for the great f-speed or Edge HD for the focal length? Focal length probably, because galaxies are very small and you're not going to be getting too much detail with the Rasa, I would think. You definitely need a lot of focal length. How did I get into Astro? I got into Astro when I was like 14. Basically, I just got into visual astronomy and I was like, I want to share this with some people. I want to take a picture. And then I figured out that taking pictures of everything was very, very difficult. Not an easy time. I'm thinking this is going to need some HDR, MT, just like this other image. I did do a light processing of the loom. Well, at least here it is with the HDR MT. It needed to be a lot lighter, so getting the core is going to be careful. Oh, that's nice. It's inexpensive to do microscopy. That's rare to hear in photography. You know, I had an image I was editing in here. Yeah, I was blending. This is before the stream. I decided to stop editing this. But we'll just use this as the loom here. So basically I did HDR MT to get back the core. Get a bit more detail. You know the drill. Let's do a quick LRGB combine and then see what we can do about the rest of these gradients and see what we can do about the H alpha. Yeah, you can use a DSLR to shoot planets, but it's not the best. A cheap planetary camera will run circles around any kind of other thing. Any DSLR pretty much. Steel Industries. You can hand select your tube and specs, which is a major. That's good to know. It's good to know. What scares me is like warranties and stuff and buying from suppliers without, you know, having that good support. That's the scary thing about night vision, is it's like a highly guarded market and there's not a lot of good information and everything is way overpriced and the price will not come down. So it's just a very high barrier of entry and seems hostile market-wise. But if you've never had the chance to experience night vision while doing astronomy, it's you should find a way because it's very special. It's one of the coolest things you can do in astronomy, probably. Anyways, I think that's a pretty good luminance. I got the deconvolution. You even see the that HA that showed up in the LRGB just by itself. That's pretty cool. that registration go weird? Because there's like a bit of dichromacy, like pink and blue. Cyan and magenta on the stars. That's quite odd. Anyways, that's a pretty cool result. Let me save this as LRGB, not as it fits. Oh my goodness. Take me back. This reminds me of like the good old days of Instagram streaming where I couldn't get people to stop being creepy. You gotta love it. Anyways, I'm doing a DBE now. I'm gonna try to hit it with a lot of samples because there's a bunch of other random gradients, color gradients, and the stacking gradient as well. And I want to try to get rid of them. So I'm just going to turn up the shadow relaxation, make sure we don't hit the galaxy, and just try to get a fine modeling of the background going. And hopefully not get rid of any galaxy glow or anything, because that would suck. Let's see what we pulled out. As long as I can't see that rectangle artifact very well, I'll be okay. And we'll darken the shadows for that later. We also got to deal with this thing on the left. I think I might just crop it out. I think that might be prudent because otherwise I'm going to be doing a lot to this image. This was shot with a 16-inch Arcos and a ZWO 6200. So we'll get a reasonable-ish crop. Artifact starts there, crop it like that. This is sampling at like 0.2 arc seconds per pixel, so extremely high resolution. The seeing during capture ranged from an arc second to 1.5 arc seconds. So seeing was quite lovely. Sent a comment above, please check. Was that about the price or the DSLR to shoot planets? Or the price, yeah. Alright, we'll save this as cropped LRGB. And before I go too crazy, I need to get the HA and align it to this. So I'll show you the HA data. It's interesting, this wing that I see in like the Hubble image is there, but this other wing on the other side, that more spread out one, I'm not seeing it so much. It's mostly just that one wisp, which is interesting. But let's go ahead and re-register everything. This is the DBE'd image, and we'll drop it on there. Are you talking seeing wise? Oh, couldn't find any star matches. What a surprise. Pix Insight killing it again. My images never register with the setup because the stars are not easily detected in my images because they're just so large. Because I'm pretty oversampled and everything else, so it takes a bit of work to get it to actually line up. Anyways. There's our HA. Let's stretch it. Oh, the sunset's coming through. It's clear tonight, but it's windy and like 17 degrees. So I could shoot the moon. But I've got a flight to catch tomorrow morning, so I'm not really in the mood to try to go out and get pictures right now. Alright. That looks alright to me. We're gonna try to get... I only shot this image to try to get this wisp. And maybe some other stuff. We'll see what we can get out of it. I'm really surprised though that this HA wisp showed up in the LRGB data. That's pretty bonkers. My first telescope was a Orion Starblast 4.5. The greatest telescope ever invented, other than the James Webb. So there's our HA and the RGB. So I think one of the first things I want to do, I don't know, I don't think going starless is going to help us quite yet. I guess we'll avoid the starless step for now. I'm just going to hit it with some quick color noise reduction, because it's pretty chonky in the color noise, and camera raw filter will do us up real nice with that. Yeah, that's good. Maybe a little bit more. That's what we love about the camera raw filter. It doesn't play around with the color noise. And then maybe a bit of curves. The gradient definitely shows up. Fair amount there. I kind of want to try to keep this image a bit more subtle. I don't want to do a lot to it because I want to try and accentuate just the good seeing. Like, I don't want to do any noise reduction. I don't really want to do much sharpening. I just want to blend in the HA and then call it good, you know? Because I always say the better the data, the less you have to do to a picture, so I'm not trying to do a lot to this, but we might end up doing a lot. So right now I'm going to Band-Aid tool out this line artifact from stacking. Just kind of clean it up. I can even see it faintly here coming across the galaxy, so we'll have to treat this image more carefully. So we're going to try and deal with it. I'm going to make a new layer, and then we're going to... Wow, my permanence of vision is really annoying me. Anyways, we're going to blend this in by soft light, drop the opacity, and give this a blur. And I might move it around to adjust. The Orion Starblast 4.5 is a small Newtonian telescope, frequently used by beginners. It is small, but it is fast and easy to set up. I'm a big fan of it personally. Alright, did that help or not? So you can see, I don't know if you can tell on the stream, but there is certainly a dark band here, and I think I need to come in at maybe 3%. 3% to fix it up, and we'll give it another blur. Less pixels this time, maybe 10. That should do us pretty good, I think, as far as dealing with our artifact problem. Yeah, that's pretty good. I've still got a bit here on the bottom right, though. Let's kill that really quick. And this is just because, I don't know why, but SGP wasn't centering the galaxy for like a bunch of the luminance data, and I just decided I would stack it all anyways, just to kind of see if it looked good, and it looked good, so I kept it. So that's what we got. We'll save those cosmetic changes, and next, let's get in this HA data, find out how we're going to blend it in. So the HA is pretty strong, and I think it looks good on the outer wings too. I think it's pretty noisy though, so we're gonna give it a topaz, a small topazing, and we're gonna see what we get from this. Once again, my GPU is very upset at me. I'm not really enjoying that result. Usually with severe noise it looks pretty good. But I'm thinking, yeah, we're just gonna have to hit it with a normal noise reduction because that doesn't look good at all. So we're gonna go to camera raw filter to handle that. Sometimes topaz will make a quite natural looking result, and other times the result is less than natural looking. And in those cases, I just choose to not run it, and we'll just go with traditional noise reduction instead. All right, next step. This is kind of how I do my HA RGB combinations. They're a bit weird. I either go to levels or curves, and I just add my red in. I think we want to hit it with the levels. But yeah, I just give it some red, and then I'll mask this image in where I see fit to have hydrogen, essentially. We can blend it in by lighten. Lighten usually works pretty nicely. So we'll do that, and we'll just mask in wherever we want hydrogen, basically. I would like a black bucket, thank you. And then we get the paintbrush, and I know that there is this HA wisp here. Why is the X button not working? Oh, there it goes. Maybe that's not the move. Maybe we'll paint black on these regions where I know I want it to apply. And then invert the mask. Nah, there's gotta be a better way. I'm pretty sure there's a way to make like a red continuum image. Let's try that. There's a PixInsight tutorial for this, because it might look better if we follow the conventions, proper conventions. Let's get our star alignment aligned to the HA. Yeah, pixel math. I don't want to, but we might have to do it. There's a script for this, but it sucks. Alright, a new approach for the combination of HA RGB. Let's see, broadband image divided by the narrowband image will provide us the continuum map. And the continuum map multiplied by the narrowband image will provide us a blending result. So let's try that. Okay, so broadband divided by narrowband image. Here's broadband. I'm pretty sure we want to keep this linear here. Okay, we have a linear image. Broadband. Let's say you are B and you are N, and we'll get pixel math, and we'll say B by N and create a new image, and that will give us the continuum. That's a nice continuum map. Yeah. Did I miss something here? Broadband divided by narrowband. Blah, 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 blah. Blah, blah, blah. I think we're dividing by 0 somewhere. Just for shits and giggles, let's do this. We'll add 1. Yeah, that doesn't do anything. Okay. So, PixInsight said no to doing it linearly, so we will do this non-linearly. If it wants it that way, then we'll do it that way. So there's our HA, and then we'll stretch our red. Woody. My cat is running around right now. Oh, rescale result. Let's, I'm just gonna run that. Yeah, okay, it needs to be linear. To be expected. Okay, rescale result. Oh, I need to get rid of my +1. Interesting. Did you set your symbols? I don't know what that means. My symbols. It looks like the HA got inverted. That's odd. I guess part of that went negative or something. Channel extract and recombine with HA wouldn't go very well. I'm trying to isolate just the HA structures for enhancements. A new approach. You know what? I have an idea. I did try that, Joshua, and it's just giving me a clipped result. I think they need to be rescaled. So I'm gonna linear fit to the broadband, and then we're gonna run it again. And I think that will probably help, because it's just clipping to straight white when I do that. Yeah, James Webb should, but I'm not applying. I applied to a lot of observatories and NASA places. Got rejected by pretty much everything. Alright, after linear fitting, do it in a global context. Huh. That's odd. That doesn't really look like how I would expect the continuum to look like. I don't think the linear fit result went very nicely. Okay. So, PixInsight method, not going to be doing it for us. We're going to have to do this blend a bit more manually. So we'll just give it some more red. I don't want to clip it though, that's the thing. Yo, I'm glad you're enjoying the streams. I figured if I'm just sitting here editing by myself, might as well do a little stream. really all I wanted was that red streak. Yeah, my edits need a lot of improvement too. We're learning together. Yeah, as long as I can get that red streak to pop through. I think it might need a bit more noise reduction. Then we did this right. And just because the this Hubble image, sorry, not that window, this window, on the other side of the streak I want, there's more streak, but I don't really see it. I guess it's over here on the right. I'll let a little bit more HA through over there. That looks pretty cool. Of course, we've got some background masking to do, but that ain't no thing. We'll clean up the background. This was shot with a 16-inch Arcos out at Sierra Remote Observatory. – 3 a.m. at night. Go to bed. What are you doing? You gotta... If there's one thing I've learned doing Astro is having bad sleep will mess you up. So make sure you get some beauty sleep there. That's pretty cool. I'm liking it. We're gonna hit it with a despeckle. Maybe that works. No. We have to do some kind of noise reduction to the HA because it's like kind of blotchy. It's pretty blotchy. And I just want to unblotch it. That looks better. Got a fair bit more HA out of that. Imaging with the new Sigma 105, very nice. I like the Sigma lenses. I used the 135 Art for a little bit. It was quite lovely, pretty enjoyable. Oh, okay, hold up. This looks pretty cool with more curves. I don't think we're out of the woods yet with this little blend. There's a cat coming to visit me. Come on, Annie. Come on. Yeah, we got the kitty on stream. This is Annie. Let me turn the light on here. Oh, it's getting dark. Oh, hi, boo-boo. He sits on me while I edit. He's a good little boy. What are you doing? What are you doing, Annie? His name's Anakin. That's why I call him Annie. Oh, he wants to, Oh, goodness. Yeah, okay, there we go. The CAD likes to sit on my shoulders, so we let him sit. I think that's pretty good. Hey Chuck, what's going on? I'm just chilling with my cat. Hi Annie. Oh, what do you see? What are you looking at? Yeah, we are editing some M106 data. He looks comfy. Yeah, he's nice and warm. This is like having a nice heated blanket right now. He sounds pretty happy too. Yeah, anyways, I'm trying to do the HA blend right now, and I'm just trying to decide if I'm happy with where it's going. I think I like it. I think it's good. Let's say HA RGB, and we'll save the layers. Dew heater, yeah. This little guy's my dew heater. It's hard to say what else to do to this image. I think I want to saturate the blues more, and that's probably all I'm gonna do. Other than maybe accentuate the star spikes that are a little faint. That could look better. This image really doesn't need anything, and I feel like I'm gonna just make it worse if I try to do stuff to it. Because as it stands, this is like one of the most detailed probably images of this galaxy. And if I try to edit it, it's just gonna not be one of those anymore. But I think we could do with brightening up the outer wings of the galaxy and also giving them saturation. And along with saturation, of course, we need more color noise reduction, which you hate to see. Like, I don't want to add a bunch more noise reduction. Ow. Oh, God. His nails are long. What are you doing, Annie? Alright, we'll apply this in a selective way. And then give it a little blur. A fair amount of blur. Maybe a lot of blur. We'll see. I just want to keep it natural-ish. And in fact, I'll probably maybe drop the opacity of this a little bit. But I want it to be more blue. I want that kind of blue. I don't want all this color noise though. I want more blue and I want more, ow, cyan. Okay. We're doing a little gymnastics today, I guess. All right, Annie. Maybe try to give it a bit more contrast here. Oh, all on one shoulder. Are you trying to get on the table? You want to get down? Here, come on, I got you. Get on, you can get on the table. Yeah, boop, boop, yeah. He wants to get down, but he doesn't know how to get down. All right, are we just gonna sit here? This is what happens when I try to edit. If I fits, I sits. All right, I'm gonna slowly sit back up and we'll see how he reacts. Digging my nails into my back. Yeah, that's real good, Annie. Thank you. Oh yeah, there we go. Oh. He's done. Thanks, Annie. That was very kind of you. To sit on me on the stream. Oh, yeah. Yeah, this is what I want. I want blue. And I want a little magenta. We're just going to absolutely deep fry the color balance, and it's going to be great. You know, I just want a little bit of this in the middle, too. Kind of get that blend more normal, you know? That's good. Let's make sure we don't forget the other galaxy. This little guy. He wants some blue, yeah. Here I go saying that I don't want to do a lot to the image, and then I just absolutely smash that blue color balance. But I think you can agree it adds to the vibe. Definitely the vibe is better. The vibe was just a bit off before. Maybe we can do less like that. Yeah. That's the ticket. Yeah, I'm going to do more of these streams, some more Ramsey, so I'm trying to grow my YouTube. We want to grow the YouTube, and I'm sitting here editing. I might as well share the editing. So definitely going to be doing more of these. Just trying to integrate it into my normal editing life. And enjoy your beauty sleep. I hope it's nice. Alright. I don't think I want it as much on this galaxy anymore. We'll take it back a notch. I want to saturate the red more too. So we're going to saturate the red. Yeah, blue is the move. It's all about that the color contrast, you know what I mean? We want the blue and the red, and it looks good, and we don't have to try to hide from the fact that it looks good just because it's maybe not accurate. This is art, not science. I'm just trying to feel this one out. You know, I don't want to overdo it. That's what I'm so scared of right now. We'll just save this where it is in case I do overdo it right now. I think... no, I don't want to do it on the mask. Hold up. Getting the core nice and dark. I like a dark core because I like seeing in the middle of the galaxy, and having it bright like this, while, yeah, it's... the global brightness is more accurate, I want to see the core. Like, I want to see all this stuff going on in here. You know what I mean? So we're going to try to incorporate more of that. And hit it with a quick blur. 150 pixels. And then we're going to adjust our contrast. So the local contrast, I think, with that is better. And it's hard to want anything more from this. Yeah, dark core is nice and spicy. It's just an insane set of data. What I want to see here as well is the RGB data had really good seeing, and it was kind of off the charts in terms of sharpness, and I'm just kind of curious to see what maybe we could do about that, because if it's way sharper in this, then I think maybe we try to get some of this RGB luminance data. So what I just did there is I extracted the loom out of the RGB data. What did I save it as? RGBL. We're gonna align this and we're gonna see if we can incorporate it at all into this other image, just because it's sicko mode levels of sharp. Like, it looks like I lucky imaged it, but it's 10-minute exposures. So something needs to be done about it. And I'm gonna try to find out what that is. First step is to make sure we get this aligned, and I know I could just do it in PixInsight, but I'm trying to save some time. So we can set this to the loom layer, brighten it a bit to match. Or at least relatively give it curves to match. And then we can try to blend it back and see what kind of extra sharpness we get out of it, maybe. It is still a little misaligned, I can tell now. Now it's aligned. Okay. Now we just need to... I need to do some better matching curves. We might have to redarken the core. And that's okay, but at least it's going to be a bit sharper. Because this RGB data just kind of slaps. We'll give it a blur. 150 pixels is fine. Yeah, okay, we'll want to redarken the core, but the seeing was just way better when I did the R data, I think. Or just when I was doing straight up RGB, that it's worth bringing it back in. And then we'll give it a slight core redarkening. A small one. And that's pretty schwanky. It's pretty good. Looks like my edges got brightened up in one of the Gaussian blurs that I did. You hate to see it. What did I save this as? Editing 1? Oh, I already have that open. We need to save it as editing 2. Yeah, LHE could look good. We'll try it. I don't want to do too much of it though because it's gonna... I said earlier I didn't want to hit the deep fry button on this, and we are slowly approaching the deep fry button. There, edge fixed. I have to use the restroom really quick. This cat is not going to be happy with me. He's not happy. Look at him. Aww. Here, wait for me in my chair. Be right back. Okay. I've been deep frying all my images and I still like the way they look. Me too. Me too. That's just a really cool picture. It's so cool. I love it. Okay, we'll say this is editing 3 even though I didn't make any major changes at all. File, close all. Get out of my face. Editing 3. It's too good. You know, it's kind of scary when the image data is good because then if it looks bad, it's kind of all your fault, you know? Like, you've got no one to blame but yourself if you mess it up. You know, I think a little LHE on the core might be good. I think it might look pretty cool. Maybe not that much. We need to show some self-restraint here. Yeah, I think I could be convinced to add a little bit of that to the core. So we'll do it. It's all about that local contrast. I mean, just look at it. This is such a small part of the sky. This is messed up. Good, in a good way messed up. All right, everything in moderation. We'll come in at a small opacity and it'll be tasteful. You know, maybe here I go deep frying again. Maybe these outer bands could benefit from a little bit of that. Yo, hold up, look at this. Look at this edge on background galaxy. Little silver dollar. That's cool. It's so small. You know, these people who probably live on like this edge of the galaxy probably get some pretty sick well, not Milky Way. They get some sick M106 way pictures. Sick, not 6. Because they probably get this big HA band, coming off to the left. So when they look to their Milky Way core, YouTube stream is freaking out at me. Maybe my Wi-Fi is dying. I don't know. Anyways, they probably get a sick little HA spike when they do their Milky Way. You gotta have a modded camera if you're shooting from that galaxy. Never thought about combining them like that. Yeah, it's a pro tip. If you like parts of one image, then you just bring in those parts of the image with the mask that you like. You know, you can be selective about it. But this is so sick. This is really cool. We'll hit it with another camera raw filter and see about saturating the blue some more. Just a little bit more. That's cool. That's too cool. And just for you people joining in, or I'm just reminding everyone of the fact, I haven't done any noise reduction to this. Zero, well, excuse me, I did color noise reduction, but as far as loom goes, there's no loom noise reduction. We're keeping everything clean. It's all natty, as they say. That's cool. All right. We'll save this. I want to add some glow. I think this image is kind of asking for a little bit of, just a little bit of atmosphere. I always like to do this to all of my pictures. Actually, you know, before we do that, before we go about adding glow, I haven't done any star reduction at all so far to this, and I don't think it will help. I doubt it will, but we're gonna try it. So I'm just gonna run Star Exterminator on this and we'll see what happens. The target view appears to be linear. Excuse me, Star Exterminator? This is definitely not linear. The cat is back. Come on, Annie. Come on. Come on. Come on. Yeah, come on. Yeah, there you go. The cat is back. You wasted no time. I'm petting him to the beat. I'm curious to see what result we'll get from this, since Star Exterminator is saying that it's garbage. Ooh, cat is digging his nails in. Do you want to sit back up on my oh, he doesn't want to go on the shoulders. Okay. This is taking a bit longer than it normally would, just because of GPU streaming. Since it is taking a second, let's plan out what we're shooting tonight. Let's see if it's clear first off. Check the SRO. Skies are looking good out of SRO. Got some quads and a car out. I wonder if anyone's working on some scopes today. Well, let's plan out what we're going to take pictures of. What do you guys want to image? I don't really know what's good right now. I've kind of been on M106 for the last forever, so. Black Eye Galaxy. It's almost sombrero season. I have been shooting sombrero with a different scope, but I think maybe Black Eye. Let's sign in really quick. Let's see, Black Eye Galaxy with 600 and the Arcos. So we can get pretty close on Black Eye. M104, of course. Let's sort these by transit, see what else we can get. That's not a very nice transit sort. Sunflower. Let's see, that's M63 if I remember correctly. M63 has a pretty lovely transit time. Hi, Annie. You know, that's probably the move. It's that, M63 or M64. With the moon being out, I think I can get a better image of M64 faster. But I will agree it's less visually interesting than the other one. Is the Fireworks Galaxy out? Not until later. Huh. This is a challenge. Okay, let's sort galaxies by size. We could do actually, hold up. I have to show you guys a picture. This is not the one I wanted to show. Mark Hansen. This dude shot Markarian's chain with hydrogen. Like the eyes and everything else, and I'm very impressed by that image. I think that would be really cool to get that. Let's see if I can get is there a higher res version? No. But you can see, like, there is HA there, and no one ever captures it. And I'm wondering what we could do about that. Looks like his field of view is significantly wider because I don't really get the eyes. The eyes are these two companion galaxies. Maybe those are the eyes. No, they're not the eyes. Maybe that's not the galaxy I think it is in Markarian's chain. What are those galaxies? Oh, okay. It's not M87, it's another one. Have you tried shooting Stephen's Quintet? No, I haven't. But this would be a good scope for it, not gonna lie. Man, I'm like so zoomed in with this, it's difficult. Let's check. We'll look at Stephen's Quintet. We are not in Stephen's Quintet season, that's for sure. Jesus. So we could do Markarian's chain, but we're going to be fighting the moon. I already did M101. Yeah, M86, I think that's the one. M81 would work. M81 could be really good. NGC 4565 would be good. 4244 would be good. Those aren't really visually interesting, though. M94? What is this? Is M94 good? Is this pretty enough? It's interesting. Oh, I wish I could do M83. That would be cool. Yeah, maybe Sunflower Galaxy is the move here. M82 is another option, but I don't really care to do that. Whirlpool. I think I already did Whirlpool. Tiger Eye. Black Eye. What is this? M98? That's kind of cool. I'm kind of vibing with M98. We'll think about that one. M90. Man, these are some Messier numbers I haven't really seen. M98, M90. These are those rarely imaged galaxies, aren't they? M66. Isn't this in the Leo trio? This is Leo trio. I could do the hamburger. I don't want to do anything in the Leo trio. The Leo trio makes me sick. I don't want to image it anymore. Barred lenticular 4762. Yo, that's really cool. 4762. Let's remember that. I really like that one. Barred lenticular. M100, I've done that before. Oh, this one's really cool in Sextans 3115. I need to write these down. Let's see, 4762, 4535. I'm kind of just trying to look for cool barred spirals or barred lenticular. It is antenna season, but it's a bit too low for SRO for my liking. I hate galaxy season. M84, what is that? Ow. Part of Markarian's chain. The Spindle Galaxy, M102. That looks rare. Yeah, okay, I think let's check 4762. With the framing, and I think, what was that? It was a double galaxy or something. And we'll see if we like it. And if we do, that will be the target for tonight. Yeah, that's pretty unique. I like that. That's unique. I need to shoot more things that I haven't shot before, and Galaxy Season's kind of the time to do it. So we'll roll with that. NGC 4762. Two pretty big galaxies next to each other. Can't complain. We'll try to get a bit of loom in before the moon gets too much brighter. And we'll just go for like a couple nights of loom. Let's see, we're gonna start it pretty late, it looks like. 9:35. We'll end it at 5 in the morning. Hit run. And then we just wait. Alright. Oh, I didn't want to close that. Cool. Scope is set to run some weird galaxy pair. Interesting starless result. Definitely interesting. We deleted the middle of the galaxy, but it's okay. It kind of looked like a star anyways. Yeah, I don't think we're gonna get much value out of that. Actually, you know, we could try something. No. There's not much to be gained from that. I'll try it in here really quick. I'll just give it like an absolutely massive high pass filter. I was gonna see if I could maybe brighten up the lanes in the galaxy a little bit. Just a little lane brightness. See if we liked it. It's okay. We'll give it a bit of opacity. We'll call it good. Okay, we were gonna add glow next, so we're gonna hit this with a blur, a Gaussian blur, a big one. We're gonna flip our blend mode to screen, adjust our levels, and hit it with some masking to retain our brightness and local contrast in the core. And then we'll give the same treatment for our little friend on the right. And you can see it just adds a bit more mood, a little bit more mood to the image. A little glow. Maybe drop the opacity a little bit, 75%. Yeah, I could work with that. It's brightening up one of our stars here, so we're just gonna mask that. Okay. We're chilling. Alright, we're gonna hit it with star spikes. And then we'll probably call it a day. Not like that, though. That's too much. Okay. The first thing you want to do, you want to match angles. Alright, angles are matched. And we'll decide what stars we want to be spiked. How intensely you want them to be spiked. I would like a little bit of saturation. Yeah, diffraction spikes are a lot of fun. We want to make sure we hide some of these spikes in the wrong spots. I don't want any in the galaxy in a big way. And I think I'm going to drop the opacity of these a lot too. Oh, yeah. I want some more orange ones. Give me the orange. Yeah. There's too many blue. Too many blue ones. I want some orange. I think I want these to be longer and fainter. Longer and fainter. And then we're going to drop the opacity of this on the outside. Okay. Looks not bad. So the goal is to just have these looking kind of natural. Not overpowering, but to give an aesthetic star spike that could happen if we had like 1,000,000 hours of integration. And I think that's pretty tasteful. It's called Star Spikes Pro. Definitely check it out. It's a cool program. Man, there's so many faint galaxies in here. So many. Let's try Star Shrink. Maybe a little bit of Star Shrink could be good, but I just did Star Spikes, so I don't know if this is really advisable. Well, I'll hit it with the Star Shrink. Yeah, okay, yeah. Sometimes Star Shrink will make morphological changes to dark nebula or galaxy structures. And you want to remain cautious in masking out those morphology changes. So I'm just going to quickly mask the core. Man, this picture goes hard. It's dumb. Okay. We'll save this as finished. I'm going to resample this. And then I'm going to drop it in a group chat really quick. Just to flex it. Maybe a bit of curves. A little bit of darkening. Yeah, okay. Whew, that's so good. Let's see, M106. And then maybe we can submit an Apod on stream. Would you guys like to see me submit an Apod? So you can all see how I submit Apods and maybe mimic that. That would be a pretty good resource because there's not a whole lot of that out there, I don't think. Let's see. Yeah. We'll pull up the image here in big mode and just take a gander. pretty crazy. I think part of it just has to do with how high this thing gets in the sky at SRO. It's pretty much zenith from that latitude, so seeing is definitely not a problem. Say this is finished M106 here. And I'm just going to drop it into my finished images SRO folder. And then we're going to send this off to Keith. He is one of the owners of SRO. So let's give it a send. But let me know if you want to see me submit this for an Apod, because I can submit it right now. Crazy. Now the question is, how am I going to edit a reel off of this? I think I have an idea of how this could be made into a reel. I think I could be like, I wanted to recreate the Apple background or this Apple desktop. That would be a cool video idea. I want to find which image they use though, because I know that this was a default Apple background at some point. I just don't remember which image it was. Let's see, default Apple Galaxy backgrounds. And then I can just make a story about how I tried to recreate it. That would be a good video. I'm positive that this Galaxy was one though. Do you guys remember this, right? I'm not smoking crack here. M106 was one of the default images. It may have been that one. Or it was like one of these ones. No, it was this one. I don't remember. Man, they really deep fried some of those. Okay. All right, let's submit for an Apod. Someone said yes, so we'll get it done. First step. is we're going to drop a watermark. We will say Bray Falls. And the font needs to be way bigger, evidently. Crack. Yeah, I know, right? Okay, first off, this font is disgusting. We need a more tasteful font. I downloaded a bunch. What, Europa Regular? That's pretty good. Europa Regular. You gotta hit them with the tasteful font to start. A good tasteful watermark. One that's not too in your face. We're going to cast this to 8 bits per channel, and then we're going to save it as M106 underscore Apod underscore submission. And we'll make sure it's a JPEG. And we'll say OK, and then I'm going to pull up my email. Make sure I don't have any incriminating emails open. Okay, here's my email. First things first, I'm just going to attach this picture to the email in a way that it's evident for them to see it right away. All right. So first off, when you're submitting an Apod, you got to get the recipients down. So it's Robert Nemiroff at mtu.edu, and Jerry Bonnell, jerry.t.bonnell at nasa.gov. And I'm going to title this Apod submission M106. And just to keep it informative, I want to maybe say deep field, because a deep field is kind of a good representation. This is a very high resolution, very deep image of M106, so we'll say deep field. Make it a bit bigger. They say, hey, Robert and Jerry. And then we're just going to write a quick write-up about the galaxy. So to start, we need to actually learn about the galaxy really quick because I don't know anything about it. So M106, what is this? It's in Canis Venatici. Okay, we'll say here is an image I recently captured of M106, an intermediate spiral galaxy in Canis Venatici. Let's see, how far away is it? M106 is a water vapor megamaser? What is that? The equivalent of a laser operating a microwave instead of visible light on a galactic scale that is seen on the blah 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 blah. Water masers are useful for observing nuclear accretion disks in active galaxy. The water masers in M106 enable the first case of a direct measurement of the distance to a galaxy, thereby providing an independent anchor for the cosmic distance ladder. Okay, so when you're submitting an Apod, you have to keep in mind this isn't like a photography competition about how good your picture is, although that helps, but it's also about whether or not you can share an interesting story about an image. And we should also check if they've recently picked one as Apod. And it looks like the last time this was picked as an Apod was 2020 of May. And my image is better, so that's fine. You want to make sure you didn't recently submit the same object, because obviously they're not going to do the same object 2 days in a row. But you also want to communicate an interesting story. You know, like they have to write a story about every image they submit. So what is a megamaser? We have to learn more about that. It's a type of astrophysical maser. So a maser is a naturally occurring source of a stimulated spectral line emission, typically in microwave, molecular clouds, comets, planetary atmospheres, stellar atmospheres. Known species. Weird. Okay, so it's not like a HA emission. So we have to figure out how to like wrap this into a story that they can easily write something from. Like a story to go along with the picture, which is going to be about the mega maser in the galaxy. Oh, it's a water vapor mega maser. That's weird. Okay, so we'll say M106 is a special galaxy because of its water vapor mega maser. What is that? The equivalent of a laser operating in microwave. So we'll say that this is like in microwave light. That is seen on 22 gigahertz line. The first case of a direct measurement of the distance of the galaxy. Okay. The water maser in M106 allowed for the first measurement of the direct distance to another galaxy. So this gives Robert and Jerry something to write a story about, which they will like because it makes their lives easier because they have to write a story every single time they pick an Apod. So okay, here's an image of M106, an intermediate spiral galaxy in Canis Venatici. M106 is a special galaxy because of its water vapor mega maser that allowed for the direct measurement of blah blah blah. I wonder, when did that happen? Let's see. Thereby providing an independent anchor for the cosmic distance ladder. What's the cosmic distance ladder? It is a succession of methods by which astronomers determine the distances to celestial objects. A real distance measurement of an astronomical object is possible only for those candidates that are close enough to Earth. The techniques for determining blah 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 blah. Several methods rely on the standard candle. That would be like a type 1a supernova. So this is the ladder. The extragalactic distance ladder. So I guess this is like a metric for measuring the distance to everything. NGC 4258 maser. Let's see, NGC 4258. Okay, so yeah, this does have a place in the ladder. So this is one of the things that we use to actually measure the distance of everything, which is pretty cool. That's crazy. Okay. So we definitely need to mention that too. So we'll say adding an independent measure to the cosmic distance ladder. And I'm going to check what that is exactly again so I can summarize it. So I guess we can say that this is kind of like a ruler for measuring distance in space, adding an independent measure to the cosmic distance ladder. Could we say that that's a ruler? It's okay, we'll say kind of like a giant space ruler. All right, so that will be our story. And we'll say this image was captured from Sierra Remote Observatory, the large 16-inch telescope under good seeing conditions. We'll say about 1.2 arc seconds. We'll say 1.2. We'll say this telescope used a very high-res camera combined with good seeing led to some amazing details being shown. Such as the big HA jet on the left. Okay. And we'll have our technical details, which will be equipment. So we had 16-inch Arcos telescope. We had a ZWO 6200 mm CMOS camera and a Paramount ME. And we also had an SX, we'll say active optics unit. And that'll suffice for our equipment description. And next we want to settle what our exposure details are, which I hate doing, but we're gonna do it because we gotta do it. So we're gonna go to our M106 folder, we're gonna go registered, and we're gonna count. We had 15 blue, so 15 by 600 seconds blue. We had green, we had 30 by 600 seconds green. Cool. I think we were also at 30 red. I think I kind of was lazy with capturing blue, and that's why there's less. Yeah, we had 30 red. So 30 by 600 seconds red. Now we gotta count our lumen and our hydrogen. And I had 112 luminance frames. And I also had a fair amount of hydrogen in here. We had, it looks like 59. Oh, only 36 of them got registered. I think we are having guiding problems. So 36 HA, now we gotta add that up with the calculator app. So we had 15 plus 30 plus 30 plus 112 plus 36. So that's 223 exposures, that's 600 seconds. 133,000 seconds divided by 60 divided by 60 leaves us 37 hours total exposure. 37 hours. And I'll bold these. I have our total 37 hours. I'm going to underline it as well. And then we want to find a way to attribute credits. So I'm just going to credit my Instagram. It never results in that much traction, but we're going to credit it anyways. So we'll say if selected, please credit and tag Astrofalls on Instagram. Because they do post to Instagram, so you want to give that credit there because they will attribute. And just to make it easier, I'm going to indent that. So that's like the gist of an Apod submission. For me at least, you want to have a nice image, have an interesting story, make that story obvious and easy, and give proper technical details and give proper credit attribution, and ideally have a watermark because they have to add one for you otherwise, and sometimes they don't, and they might just look at it and say no if you didn't have one. So that's what you need to look for when you're submitting an Apod. And this has worked pretty well for me. I haven't gotten one in a while, but I haven't been submitting. So yeah, that's how you submit for an Apod. We'll send that out, and then we wait. And next I have to think about how I'm going to make a reel of this. Let's also check what the 24-inch is doing in Texas. I don't think it's doing anything right now, but I'll text Christoph and ask. Alright, I think that's enough streaming for tonight. I'm glad I got this image done. And I hope you guys learned a little bit of something maybe useful. At least how to submit an Apod. I'm sure there's not a lot of resources out there for that. So that can definitely be helpful to you guys, I think. Alrighty, well, I am going to play some video games now and pack for my flight, but I hope you all enjoyed the stream. Oh, we're going to get more of those streams. This remote observatory, only I am running it, so no access to that apart from the data. You can subscribe to SRO's program. Hey, it's everyone's on their own personal journey, you know. You can make whatever you want out of it, so don't be worried about your own progress in a hobby. All right, guys, have a nice night.